In this video series, I'm going to restore an E&L MMD-1. On the screen here I have a photo of an MMD-1 I owned quite some time ago, probably about 15 years ago. One time I had a collection of MMDs and other equipment that E&L produced in the 70s. Looking at this device here, the picture quality is pretty poor here. This is a 15-year-old digital camera. But I can read that the date code on the 8080 is 52nd week of 76. I don't see the revision number of the board here. This went through a number of revisions. I think this is actually a later unit, partly based on the keyboard that's being used here. But what was the MMD-1? Well, it's the Mini Micro Designer. It's an 8080 based single board computer. It's designed to be used in an education environment. So it might be, a college computer lab. It might be at a company who's looking to start using microprocessors, in their devices, etc. It's a very simple machine. There's an EEPROM. I believe it's a 1702. Don't quote me on that. With this KEX code in it. So this label is a label I put on this machine. KEX is the keyboard executive. So KEX is the monitor that takes care of reading the keyboard, driving the LEDs down here for output, and basically making the system run. You can see here again it's designed for kind of an educational market. So there's of course the processor, there's bus drivers, so the processor can talk on a bus. There's a clock generator here. I think it uses a standard 8224, I believe, as the dual phase clock generator for the 8080. Again, don't quote me on that. There's a memory block decoder here. Why does that socket appear empty? And there's a memory decoder that decodes whether it's talking to ROM 1, ROM 2, or RAM. There's a small amount of RAM. Here it is. There's some RAM right here. I think it's got a total of 1K bytes, if I remember correctly. So, of course, the memory decoder is whether I'm talking to RAM or ROM. If these are, if they're, I don't know. I'd have to look at the schematic to know the layout. But there's that. There's some I/O decoding for ports. There's some buffers for driving this edge connector. There's this keyboard encoder that takes care of talking to the keyboard. And there are these drivers for 24 LEDs down here. So if you look close, you may notice that the keypad down here goes 0 to 3, 4 to 7. There's no 8 or 9. And then there's some control stuff here. And that's because this is a purely octal machine. If you've used octal, you understand octal only has the digits 0 to 7. So if there was a 255 decimal, here it would be displayed in octal as 377. You might be more familiar in hex, where there would be two groups of 4 LEDs and it would read FF. This is a purely octal machine. If you look at the early days of the 8080 microprocessor, they talked octal. This becomes even more interesting, and then it's a split octal machine. And what I mean by that is if we're running where the address bus is being represented here, so A0 to A15, and the data bus here, data 0 to data 7, notice that the address bus is broken up into two blocks of 8 bits. So if we were at the absolute top address, where all the address pins were 1, you would read it as 377, 377. If it was in pure octal, this would then become a group of 3 bits. This would become a group of 3 bits. This would become a group of 3 bits, and it would read 1333, or take that back, 17777777, I believe. So split octal basically splits the most significant address from the least significant address. So it's simpler to read, 377, 377. This was pretty common back in the day. There's a prototyping area, obviously, on the board. There were control and address pins that are brought out, I believe, I know they're on this edge of the board, some number of pins on both sides, and then it kind of leaves about 2/3 of the board for prototyping. It brings forward +5 and plus and minus 12. There's also a voltage regulator built on the board here to produce the +9 for the 1702 EEPROMs. I actually think I can read 1702 there. They have a +9 voltage rail, and this is a Zener circuit. There's a Zener diode sitting right here, I believe, or maybe here, I don't know. And there's a Zener voltage regulator to produce the +9. So, it's a simple little board. Oh, this is a Resale. I do see this on the silk screen here. So Resale is a much later version, which is why we're looking at 76 date codes here. So let's take a little bit closer look at some things. Like I said, the prototyping area here. This one isn't labeled well. The keypad, I also know this is a later generation machine because of the keypad being used here. It's a standalone keypad. There's a bunch of solder pads under here that it's soldered to. Sorry, I got a dog doing something. Fuse on the back, power switch on the back. Anna, go lay down. You're clicking your toenails. Internally, it's exactly what you'd expect. There's transformer. There's 3 rails here. There's a 7812, 7912 to get the plus and minus 12 volt rails, and then there's a 5 volt regulated power supply over here. I may have a more close up of that board. I do. So a couple of 3-pin regulators, and then there's this pass transistor and a 5 volt regulator over here. There's 3 different taps coming in off the transformer. AC tap in, full wave bridge rectifier, capacitor for smoothing, and then a voltage regulator. And same thing here, and then a larger diode bridge, just because the plus 5 is going to have much more current load on it. And an adjustment, pretty typical for the era voltage regulator. Those voltages regulated are brought up to the back of the printed circuit board here on these 4 connectors, and you may have noticed these in the photo. These guys, we can actually scroll back to the original picture, where there are 4 screw terminals here, these nano jack terminals, where you can pick up ground, plus 5, plus 12, and minus 12. So you could, bring those off to the board down here or other prototyping boards for experimentation or circuit design. Look at the back of the PCB. It is a double-sided printed circuit board. They used a black silk screen on the front, which I personally hate. These 2 rows here are where the pin headers to the ZIF socket, or not the ZIF socket, the prototyping board would be connected so that you get whatever these signals are brought up directly onto the board. I've got other examples of this where those are actually labeled and connected. Apparently on this one, it was waiting for me to come up with a way to reconnect these. Bank of pull-up resistors here that are intentional on the bottom of the board. Just looking at the way the pads are laid out, I think that's actually intentional to be on the back of the board. Or maybe it really did make it easier for assembly. I don't know. So we've looked at one here that I worked on 15 years ago, probably. My entire E&L collection was sold off some point a long time ago. Need to scroll up here. This is the one I recently acquired, this unit. I picked it up on eBay. 2 things attracted me to it. It's got the MI card here on it, which is a memory and interface expander. If you noticed on the other one, it was a connector down here, and this runs a ribbon cable up to this board. This board provides additional space for ROMs, additional space for some RAM, a couple of UARTs, and there's a couple of interesting connectors back here that are for a cassette recorder and external RS-232 or 20 milliamp. This one's got one of the labels still attached to it here that designated what these pins were. There used to be a label down here for these pins that's long gone. It's a later generation unit simply because the power switch isn't on the front, and it's got this improved keypad. These photos were taken by the eBay seller. I didn't take them, and I appreciate it. He did a good job with the photos here overall. Phase 2 on last pin, so it looks to me like they probably brought phase 2 over to some place on the connector here. Phase 2 would be the second clock signal. So we in the first picture I took a quick look at, there was a clock generator circuit on the board, and the 8080 has phase 1 and phase 2. It requires 2 clocks to operate correctly. You can see that it's got the same 4 jacks here, and that's because power is brought up, and we'll look at this in a minute, from the main board onto this board using those connectors. A little bit of detail, it's Rev F of the MI board. You can see a little bit more here. You can actually read the label here. He apparently powered it up. It's showing Address would be 003000117. So address on these two data down here. I have no idea if that's legit or not. View at it from the side, it's got this nice wedge case to make it a little bit easier when it's on the workbench in front of you. And you can see here where there's the original binding posts underneath, and they've used wires to connect to the upper board. That's the correct way of assembling it. That really is how this was designed to work. So like I said, this is the unit we're going to restore. Good view of that ribbon cable and these kind of odd connectors here. So let's, I kind of screwed up here. I should have had this position better. So let's look at a few other things here. Let's go ahead and look at the E&L catalog from back in the day. Based on the orange color here, this just screams at me mid-1970s. This orange, in my memory, was all the rage. I would have been 15 probably when this catalog came out, and I'm guessing about 75. And it jumps right into, the MMD-1. It talks about everything we've just talked about, clock generator and processor and keypad. Anna, please lay down. Block diagram, in kit or fully assembled. I would have loved to have assembled one of these in the day. Couldn't have afforded it, but it would have been a really interesting learning tool. Talks about the memory, the MI card, what we're going to restore one as well here. So, it's a neat little catalog piece. This particular manual comes from my collection. It's something I scanned and cleaned up at some point. Gets here into, here's an EEPROM eraser. There was this MMD-PP programmer. I actually may have skipped past that. This was an actual 1702 EEPROM programmer that attached to the MMD-1. He had a programming socket and a read socket. Some S100 cards here. So there's a prototyping card for S100 and maybe an interface card of some kind. I don't know. S100. The MSI was, really was a thing by this point, as was the Altair, I believe. There was some kind of a video interface adapter. I never saw one of these. And there was these things called outboards. And outboards plugged into the little white prototyping boards and brought basic functionality forward. You see these for sale often on eBay and on Tindy and other places. And this is a little power supply board that plugs into one of those prototyping boards that brings, +5 and voltages onto the board for prototyping. This is from 1975. They were doing the same thing all the way back then. So, you may look at this stuff and think these breakout boards are a modern thing because of the Arduinos and things. No, breakout boards and these kind of boards, here's pictures in the mid-70s of the same thing. We've been doing this kind of stuff for a long time. Data transmission outboards, digital analog outboards. In my collection, I had a bunch of this stuff. Like I say, I sold it all off. It kind of is what it is. I regret selling them at this point, but it really is what it is. So, it's a nice little manual. It's an interesting view back to that point in time. Daisy. Wow, when I start recording, the dogs just have to get up. I've got the Bugworks manual here, so you may, in your history of early vintage computing, seen a series of books called the Bug Books that were basically digital logic, the 8080 processor, that kind of stuff. This is the catalog of the complete Bugworks, and this is companions to those books. The Bug Books were written by Titus and I believe a couple of people who were, the founding members of E&L Instruments back in the day. So they tie into this stuff. But Bug Books catalog, prototyping stuff. Here's some kind of a designer. Talks about these breadboarding, strips that are just common today. They produced a number of different designers. So the CPD01, kind of an all-purpose designer, some just straight, simple prototyping stations. This wedge design was really common with them. The Breadbox 3, this is basically just power supply, maybe some I/O connectors, and place to prototype. Get a little more mature ones with momentary switches and a potentiometer and et cetera, et cetera. So again, these go back to the mid 70s. I've never seen an example of this analog digital designer itself. I'd love to get my hands on one of these. To me, it's a little reminiscent of some of the stuff that Diligent's doing today with the there's a couple different units in the what's it called, the Analog Discovery series, that are a box that bring digital I/O out and have input, and again from 75, what's new is what's old is new again. Never saw an example of this, but it's another prototyping station. So there was a lot of stuff back there to help the world learn. Digital electronics. These are the bug books I was talking about. These aren't great photos, but they were paperback books, the Bug Book 1, 2, 3, etc. That was a complete course in the day on digital logic and microprocessors and I/O and A to D and just all that stuff in the world. Jumps into some of the outboards here again. Anyhow, that's another catalog. In this catalog, and this is the reason we're looking at it again, is the microprocessor systems pages, and there's an MMD-1 shown here. And the early MMD-1s had the power switch and the fuse on the front. Later generations, they moved it to the back. I don't know what rev board this would be, but it's the same basic layout. 8080 processor equivalent. Small amount of RAM, ROM. 8224 clock generator, 8111-2, 256x4 static MOS RAM. So it's an 8111 RAM. There's 4 of them sitting here. I guess to get you 2K. Does it actually have 2K? Interesting. 2048-bit, 256x8 programmable read-only memory. There's 1702 ROMs. There's, in this drawing here, the Kex ROM here. The EEPROM programmer, we kind of looked briefly at that earlier. An external hex keypad, more prototyping stuff that kind of duplicates some of what we went through. Some design aids. These are interesting in that they are stick-on decals that you could put on top of logic chips to basically show the gates inside. I've seen some kind of modern versions of this kind of stuff. It's actually kind of cool if you're just, I think, coming up to speed. So there's another catalog that talked about MMD-1. We'll jump in here and look at the February 178 resale price catalog. So I know the MMD-1 pops up in here. MMD-1 assembled $600 as a kit. I don't see the kit price here. But $600, and we're talking 1978 $600. That's probably $2,500, something like that. In modern currency, there should be the MI, and there's a bunch of versions of the MI, but 250, etc. So this stuff wasn't cheap back in the day. I guess a university or education facility could potentially pay for this stuff, but interesting stuff. So this may look familiar to many of you. This is an 8088 instruction reference card from E&L that isn't octal and hex, but here's an instruction card from probably the mid 70s. I'd guess 74 or 75 on this card probably. It was a little trifold card, and just it's a standard thing that if you've been doing this for a long time, you're used to seeing. This however gets into why octal is interesting on the 8080. So LXIB, a register, and if you look at the LXI bits here, let's see, in octal, it's a 001. Actually, that may not be a good example. Some of the opcodes break down really easy in octal, where you can just look at the bits and know what the opcode is by the first 2 bits. and then what it works on against the other bits. And I'm not seeing some great examples pop out here. This may have been truer in the, yeah, L is 5, L is a 5, L is a 5, L is a 5, M jumps to a 6. So you could look at this opcode and go 153. Well, the 5 is L, the 3 is E, the H is 4, L is 5 again. So you could kind of just look at the octal code and figure out somewhat easily on some of these what the opcode actually was. So, it was interesting that because of how the 8080 decoded the instructions, it was obvious in octal, or more obvious in octal, on the bit fields. So anything else to look at here? Let's jump in really quick and take a look at the Rev H MMD-1 manual while we're doing this introduction. This is from 178 for the Rev H. They are, okay. So in May, June 76, so maybe I've got the dates a little bit wrong, there was a article published on an earlier version of this device, and I think that was the dates for it. So maybe they started in 76. I don't know the exact dates. This again is a copy of the manual that I have made from an original and done a lot of work to clean up and despec and all that kind of stuff. And it assumes you're building a kit. So it kind of gets into here about, how to build a kit, different versions of the kit. Kind of walks you through, a BOM here and where things go. I love this page, and I always have. Caution, static electricity kills. The following devices, and this is true for all of these, are static sensitive. You can kill them. I know a lot of people saying, you don't need to worry about it. With modern integrated circuits, it's less of a problem. But a lot of these components are static sensitive, so they moved on to 2102 RAMs, it looks like. -6, is that 600 nanosecond? I don't even know. Anyhow, oh no, so Intel 8111. I don't know what RAMs they used. I guess different RAMs probably have the same pinout. It uses an 8212. I forgot about that for the I/O port stuff. Some instructions here on how to wire it up. We kind of looked at a physical version of this. This is still got the power and fuse on the front of the box. We got you through the assembly, the wiring. I'm debating whether with this unit to completely strip it down to the bare PCB. Part of me would really like to reproduce the PCB and make that design available. This starts to hint at some things that are interesting here. There's, of course, the KEX ROM, and there's an LD socket here for an LD ROM, and that's load dump. This is the ROM that works with that MI expansion board that we looked at to be able to control the cassette recorder to load and dump programs to cassette. I think it deals with the regular serial port too, although I could be wrong about that. Get you through assembly, check out, very simple schematic. It's just a simple 8080 based system. It's part of why they're easy to rebuild or to repair. How to operate it. You see, 2 pages, heart of the KEX is the heart of the system. Blah 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 blah. So their documentation was pretty complete at the time. Gets into some of the routines in the ROM. Dr. Frank Settle Jr. Digital directions. There used to be a software hardware user group. Wonder if he's still at that address. He would be probably in his 70s. Or maybe, I don't know, probably not. But a dump of the KEX program listing. And notice that, again, that the addresses are displayed in split octal here. We talked about this a bit before. So it's octal for the opcode and split octal for the address. And because it's only 256 bytes of ROM, of EEPROM available, it never, the most significant byte here never goes, greater than 000. 377 in octal is, of course, FF and hex, or 255 decimal. So basically the entire EEPROM, or nearly the entire EEPROM, is used here. 357 has a return, and 360 is literally the next address in octal. So I think every byte is used. So somebody did some work to optimize to get this thing to fit in that 1702. There's then the load dump PROM program listing. MMD1 MI routines. The following are used with the memory interface board. Read from cassette. So, oops, scroll too quick. Write onto cassette routine. Cassette input routine. Teletype input. So it does talk to the regular serial port as well. So we will look at this stuff in more detail as we do the restoration. Some just basic diagrams here. Transistors were not in their infancy at this point, but there was a lot of package styles, that still existed. Some, you may have seen some of these, you may not. Most of the modern stuff we see today are in plastic, with this shape. But even then, there was different variants of this and different pinouts. So, it become important if your transistors didn't exactly match. Apparently, the resistors are on 0.45 board spacings. That's kind of nice that they told us that. We would be able to have a bender tool so we could bend them to the correct size to drop in. So nice little manual overall. There's a manual that came with the MI as well. Again, this is from my collection. This is for the Rev E of the MI. It's a manual I have scanned and cleaned up. Page was blank. Table of contents. This gets interesting as it starts to talk about things like on the MMD-1, if you had an old enough unit, you needed to, on the back of the board, bring the signal around onto the edge connector. Again, this would be looking for the back of the board. The units I have are later generations, and you didn't need to make that modification. Talks about serial data, essentially what becomes RS-232 here, but serial data, how serial data works, relay circuit to be used with a teletype's paper tape reader. So this is where the concern is. The MI with its 20 milliamp current loop includes a relay that can be used to control a teletype's paper tape reader relay. Well, a driver to control that relay. So it's interesting that the MMD in its software can start a paper tape reader running on a teletype to load software or write software, punch or read. So it really is back in that paradigm of using a teletype, which is really pretty cool. Baud rate can be changed from the factory set 110 baud. You actually replace values of a capacitor, which is interesting. Memory map. If you've done anything with small machines, you're probably used to seeing memory maps. I mean, same thing. You can see that the kex is down at the bottom, 256 bytes. PROM 1, PROM 2, PROM 3, 3K whole. I don't have the debug ROMs. I may have to see if I can find them to put on the board. A bomb, cleaner version of the static electricity kills. Again, I love this for whatever reason. I guess it takes me back to the day. I don't have the illustration. I don't think I copied the illustration into the presentation here. It's basically just a large layout of the board. How to mount the board. They're hinting at the wires here that you use to connect to the posts here. It just uses 4 standoffs, 4 screws, and a ribbon cable. It's pretty easy to put on. Pretty simple schematic, 4 1702s, a couple banks of RAM, some decoding logic, serial drivers. So here is the relay plus and minus, keyboard plus and minus, and printer plus and minus apparently in their paradigm. So interesting that you could drive the relay. This has got to be 20 milliamp. Looking at it, yeah, 20 milliamp data, cassette data format. I guess it's really both. But it uses those little odd 6-pin connectors. So we'll come back and talk about this. Notice that there's this connector body, there's pins, and there's a hood here. And it basically has you assemble your own cables here. Check out calibration. So again, it's assuming you built the unit. Software listing. So let's jump back and keep in mind that picture of that hood. Pics, which is a good photo here to actually look at. Let's see if we can find one. I talked a little bit about these before pointing them out. There's these oddball connectors back here that I really wanted to be able to get the female connectors that go on here, and that drawing of the connector and the hoods for these is what that drawing was about, how to create your own cables. Is there a better photo of those? Here they are, kind of are from the back. I did some research and actually found new old stock of the connectors, the hoods, and found the pins on DigiKey. So actually working from the BOM, I was able to figure out what the manufacturer parts were here and actually buy the connector bodies for the female pins and the hoods. I had to go to a specialty place to find those. Mouser and DigiKey showed them, but they had no stock, and actually found stock elsewhere. DigiKey actually had the female crimp pins for these, so we're going to be able to make our own cables here for these as we get deeper into this project, which will be pretty cool. There's a kind of a closer up. These are circular pins. They look rather flat there. Apparently these are a fairly common connector type in some industries, based on what I read. Boy, there's some chips here not seated well, but again, I've not even tried to apply power to this. Another view of them. So it's just, I'm rambling on here. It's fascinating to me that I was able to find the body and the hood that were in that diagram. Let's go back and look at the diagram now. That's the wrong manual. Of course it is. Now that you've seen the connectors again and have them fresh in your mind. I think I shot past it. There's the connector body that's got the clips that clip it down into place. There's the crimp pins that go inside. And there is the hood here that essentially connects over it and uses a wire tie on the end to create strain relief, which is interesting. It's going to be really cool when I get to the point of building these up. Let's say we will do that together in video and actually, produce proper cables. I think I mentioned I was able to ultimately figure out what these were looking at the BOM. Yeah, down here. Burndy, I guess, is the type of connector, SMS6H1, 6P1, but basically using those two part numbers there, SMS, 6P1, and H1, I was able to find the plug in the hood, which was pretty cool. Burndy socket tie wrap. And, between these, I was able to find it, which is just, to me, really cool. It uses a General Instruments UART, a couple of them, so AY51013. It's not a UART I'm particularly familiar with. This will be a fun project, I think. So I will decide whether to strip the boards down to the blank boards and potentially reproduce them. If that's something you'd be interested in playing with, let me know in the comments, and it may help guide me to whether go to all that trouble or not. I'd love to assemble one onto a blank board and from the manual and actually go through the assembly and the checkout and everything like you've done back in the day. I think it would be a lot of fun. So with this wrapped up, I don't think there's a whole bunch more here to talk to. I guess the last thing we haven't opened is this document, and this is just a dump of the LD PROM. Install the socket on the board in PROM socket 1 on the main board, and it's just a hex dump or an octal dump here. Again, in the ROM in split octal format. And you can notice here that this EEPROM sits in the next 256 bytes of memory. So KEX is in the bottom 206 bytes, and then this ROM sits in the 206 bytes above that. And that's why the most significant bit here has a 1 here. So, and this will run from 1000 to 1, probably close to, it runs to 1211, so there's actually room above it, because it can, the EEPROM itself can run all the way to 1377. So it doesn't use all 256 bytes. Uh, you know, cool stuff. Well, I hope you enjoyed this little intro to the project here. I'm looking forward to it. I've got a bunch of active projects at the moment. I need to actually focus on one of them and get one done. But as always here in the lab, multiple projects, multiple things vying for time and bench space. But I'll get these done at some point, and we will hopefully enjoy this together. So with all that said, I hope to see you in future videos for the MMD-1. Thanks for watching. Like and subscribe if you haven't. I know I don't normally ask for likes and subscribes, but I've decided to start doing that with the new year here. They help, and some likes might help me get a little more visibility out in YouTube land to get more people looking at the channel. To the 2,000 plus of you who subscribed, I appreciate all of you. To those that have posted in comments, thank you. I tend to reply when it's appropriate in comments. Anyhow, I've said it like 3 times here. I seem to end every video this way. Let's wrap this one up, and we'll talk soon.